Yaesu FT-857 with flashing display. Does that mean any good? If you want to know the story behind it and if you want to know how to fix it, then follow me along and we see what's really going on in this radio. Welcome to TRX Bench. Okay, a flashing display always means that there is a serious issue. So that means that there is a PLN unlock condition. And that problem really can be in different stages. I mean, of course, it can be a problem in the PLL circuit itself. But it can also be a problem in the VCO circuits, and it could be a problem with the power supply for the VCO, for the reference standard, or for the PLL itself. So you see, there are really a lot of possibilities, and yeah, we really need to find a starting point. And the first what we can do is a service reset and see if after the service reset everything is fine. Okay, first we switch off the radio, and service reset means we press here our V/M button and our function button, and then we start and fire the radio up and see if the flashing is gone, but no, it isn't. So we cannot fix it with a simple reset. So that means we need to crack the radio open, and yeah, let's first have an overview and see where we start. Okay, and here is the main board of our FT-857 in front of us, and on the main board we have all the essential parts what I've talking about. So for instance, here our VCO circuit, and here is our reference standard, and so this might be a good start off point. So let me go a little bit more here into it, and there is our first shocking finding. Can you see this here? So somebody put here a second, most likely voltage regulator on top on the, so that down here is the 8-volt regulator, and somebody put a second one on top of it. So I believe that this should be the replacement for the 5-volt regulator, which is normally on the other side of the board, and the output is here wired through or to a point here on the board, as I remember right. So this is a test point, but anyways we will find it out later. So let me see, what do we have else? First inspection. What is this here? Our focus is going out focus, so yes, looks like that this has burnt a little bit. And yeah, let's see what we have else. What do we have? Oops. Have a look down here. So this is really bad. Somebody tried to, don't know if he tried to replace this transistor here, don't know, and this looks a little bit odd as well. So, that is not really nice, because it shows that we had obviously already the golden screwdriver in. So that is really no fun. Okay, so what can... look here. So a screw is missing. And yeah, to be honest, already enough findings which I really wouldn't like to find. So that really means that somebody, maybe he tries to fix it, or he tries to do some mods, I don't know. But I don't know if he maybe damaged something, no idea. So okay, first what we can do, we can of course check if here our voltages are present. As I said, the down one here is our 8-volt regulator, and I believe that this here should replace the 5-volt regulator, which is normally on the other side of this board. And we can of course check if this both voltages are present. And then what we can do else is we can check if our reference oscillator here is supplied with I believe, is it 8 or 5 volt? We have to watch into the schematic, but I think it is a 5 volt which this reference oscillator gets. So that is what we can do first. Okay, so this here is our main board schematic, and let me zoom in, because that is the first what we have seen. And yeah, we have here our both voltage regulators, and you see we are getting our 13.8 volts here in the first 8-volt regulator, and then the 8-volt regulator is directly connected to the 5-volt regulator, so that we have the 8 and the 5-volt which is used here on the board. And yeah, that is what we want to check first. And let me see, yeah, when did I fix 857 last? So I believe somewhere here must be our reference oscillator board. Yeah, here is our ref unit. And yes, so our ref unit is supplied with 5 volt. So so in this 5 volt is from our 5 volt regulator. So therefore, yeah, let's check that first. Okay, and you can see the multimeter, and as I believe that this here is replacing our 8 volt or 5 volt regulator, I believe that this is then the input. So let's check, and I do not see nothing here. Yeah, I can't. Would be a real good idea to switch the radio on. Alright, so now the radio is switched on, and once again let me check here the input, and 7.9. Alright, so that is telling us that first of all our 8 volt regulator seems to be fine, and I'm here testing at the input of our replaced 5 volt regulator. So that means this here is the output, and it is 4.9 volt. So that is fine, no problem. Even this does not really look very professional, but anyways, it is more or less okay. And then we have of course our reference oscillator here. So let me check first, because that is easy to find. Let me check if the 5 volt supply voltage is here present, and it should be this both pins here according our schematic should be 5 volt. So let me check. Okay, 1.2, and the other one 1.2. No, that is not really promising. So that means that our 5 volt does not get here to our reference oscillator. I mean, of course, that means if the reference oscillator does not get its supply voltage, then it is clear that the radio is out of log. So, I mean, it is a little bit funny, because the output voltage here from the regulator is fine, but then here we only have 1.2 volt. So, I mean, that could mean that the voltage is pulled down somewhere, but you know, we know that somebody already was in and did something. So I really want to see the other side of the main board to see if we have additional damages, and therefore in this case, because we know that somebody was in, it is a good idea to take the board out first to get an impression if we really have a damage on the other side, because it could be that there are interruptions on the board, on the traces. So, and I do not really know what has happened to this radio, and therefore in this case it is definitely a good step. I mean, this here is a 5 volt test point, and at the 5 volt test point our 5 volt is present, but I mean, this is not really a big thing, because it is only this little wire. So somebody really soldered the 5 volt output voltage to the 5 volt test point. I mean, basically that is not really wrong, but well, let me see what you have on the other side. Okay, so the board is out, and here is our stacked regulator pair. So when we flip it now over, yeah, we see a little bit better what, obviously, let me see how much I can zoom it in, but I think you already can see what really has happened. I believe that something burnt here, and it looks like that somebody was with a milling cutter or something like that down here. Yeah, looks really like milling cutter work, I don't know. So normally this pad here and this both pads are for our 5 volt regulator, and you see that we have here a new bridge, and yeah, we have that does not really look like very promising, because here it looks like that it was cutted out somehow, but we have still traces and components going here over this area, and here we have a component with looks a little bit, yeah, odd, I don't know. So Well, what we really don't know is if our 5 volt really gets distributed from here. Maybe there is a trace still missing. Maybe a trace has been destroyed and has not been redone. I don't know. So I think I really have to carefully watch this area, and yeah, let me see if I can find the 5 volt line, the distribution all over the board, because this 5 volt is used everywhere on the board, and for me it looks like that the connection maybe has destroyed, so therefore that is the first I want to check, and yeah, then we can go ahead. Okay, so I've tinkered around here a little bit, and well, just to show it, so this board is a more layer type, so I mean that is nothing special, but I do not really know how many layers here are used, so there's unfortunately no information on our schematic, and we do not get this layer diagram, so I cannot follow the traces which are here somewhere in the layers. But what you can see here, that these layers here inside really has been, yeah, I believe really destroyed. And yeah, what I've found so far is that really the distribution here on the board is completely failing, the 5 volt distribution. So I have checked here on some ICs, and here at this socket where normally this module is in, and as well as we have done it before here for our reference standard, and nowhere we have our 5 volt available. So it really must have been a serious cut somewhere, I don't know. Now I have tried here to supply the different areas here with some bridges just to check what's going on, and here I have also installed a bridge, and I'm not sure if I really was able to distribute now everywhere our 5 volt, but this may be your first step, just to see if this is working or not, because we are very close at the point where we need to say, hey, come on, this board is really destroyed, and it doesn't make sense to fix it, because you do not know what will happening tomorrow when the board is heated up during you know, maybe a contest or whatever, I don't know. So then suddenly you have the next interruption, and beside that this here are our pre-drivers, and well, when I watch here the pre-driver, so somebody has taken the original one obviously out, and this seems to be a replacement, and this replacement has not been done very professionally, so you know, we have really a lot of question marks here with our board. I don't know. Okay, so for test purposes I have wired it up just to see if I really was able to get all the 5 volt distribution here on the board. And let's see when I switch it on right now. Is it? Yeah, it's connected to the PSU. Okay. Oh, have a look. So that is promising. So we have static back, because if we have this PLL fault indication, audio is muted, and that is now back. So that is not too bad. So let me see if we have receive and if we have transmit. Okay, so first of all, let's do our transmitter test. And radio is switched to upper sideband. 1 2 1 2 1 2. Hola, 1 2 1 2. Test test test. Okay, so transmit seems to be okay. I don't know if we have fully power dialed in, but that is not the important point right now. It is important that we can see here power. 1 2 1 2 1 2. 1 2 1 2 1 2 1 2. Test 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 test. Okay, because that is important to see if all the different stages are getting its voltage, and I'm talking here especially about the 5-volt bus, because that was the problem, obviously. Now let's see what's going on receive. Okay, and finally we have receive as well. So that now seems to be not too bad. I mean, still we have the problem, we don't know what's really gonna happening if the board gets really hot and everything. So that is still questionable. So this will finally repair without any guarantee. So it really can fail from one of the other second, and therefore what we're gonna do right now is I have to take the board out again, and then I have to do this wiring here in a more professional way. I mean, it is yeah, you can't finally do it as new, so we have to do it with wires like this, but we will do it a bit better, and after that I can really do a complete test, because of course we have now only tested shortwave, and we really have to test UHF and VHF as well, and of course we have to test all the different bands. So this is for the moment in time only the 20-meter band, and of course we need to check for AM and FM. So there is still there are still a lot of questions which needs to be addressed, and we need to see if all is working. But okay, so first of all, we went definitely in the right direction. So obviously our board 5-volt distribution is back. Okay, so I'm gonna now take it out and wire it up new, and then let's go for the next step. Okay, so what I've done already is that I wired this up here. So these are our two bridges to get our 5-volt supply all over the board. Next is that I really need to take this regulator off here, as we cannot leave it as it is. First of all, it gets quite warm, this regulator, so we need to have it somewhere where we have a heat sink. And secondly, you know, this is not really a nice solution, so it always can break off, and no, we can't leave it. So first now I have to remove this stuck regulator, and we need to find a different place for it. Okay, so this is a regulator with which I have taken off here from our main board. So this is now the situation. It is as regular, I would say, and well, so yeah, can't use this one, and I thought it might be a good idea to place a regulator, 5-volt regulator, like this here. I've already bended the legs, and this legs fits into this connector, and then I think I can do it this way here. Okay, and yeah, I only think I have to double check, but it should work. I need to get here my ribbon cable back into the socket on the board, but on the other hand I could also do it this way. I mean, it is then here in front. Yeah, it is here in front of our van, but the fan will not that much be so the airstream, I mean, will not be that much interrupted, so I think I can do it that way, and then yeah, we finally have a nice solution for our 5-volt regulator, because on the other hand I'm really do not like to place here a new one. I do not want to heat this board once again very much, as we know we have trouble enough, and therefore no, I don't do it. So good, I have this pad here for our distribution wiring, and it's fine. So we do not want to touch it more as needed. Okay, so that could be a working compromise what I've done here. So here is our voltage regulator, and I have enough chassis to get a good cooling here. On the other hand, I have here all the wiring directly under it. I mean, it will not get so hot that it will melt here our wiring, but I guess I could, just in case, I could put here some Kapton tape over it. Then we definitely are sure that nothing really can happen. And yeah, it's enough space to connect here my ribbon cable and all the other wirings which I have to do here are possible as well. And yeah, so the only thing is I need to fix it here on this side, simply with a little nut, and the rest I will cut off, and then our fan is also fixed. And well, I think that is something we really can do without having any trouble afterwards with our installation here. Okay, so I've installed here some Kapton tape. Kapton is heat resistant, and therefore we can use it for these purposes, and I believe this will be good enough to protect our wire. And now I have easily come on, I have to put it back here into this position, and then we can go ahead here. Our new wiring is now fixed with some hot glue here on the board, so that should be fixed. And then we have here another area where we need to take care, and that is down here. So you see, I don't know if somebody already tried to replace this transistor here. I really have no clue. So I simply take it out, and I take this fuse, this ship fuse out, because that is not good as well. And let's see if this transistor here is still fine. I mean, this section is not so important for the general function. It is only the interface to the, I believe, which one is it? Well, this one or this one, I'm not entirely sure right now, but one of these both is wiring for an external PA, and that is the interface transistor, and this here is a ship fuse to supply the respective voltage to it. So yeah, it is not so important, but we need to check what's going on here. Yeah, Kapton tape is in place, and I've already flux on, and now I can remove this transistor there. Yeah, I've tested the transistor, and I believe somebody has tried to solder this transistor here into this position, but he was not able to get it done, and therefore as you can see, our joints here are already clean, and that means I'm able to solder now here the transistor finally into the place, and then that will work as well. Our transistor is now perfectly soldered in, and we can go ahead. Alright, our board is back in the chassis, and as you can see, our voltage regulator is installed and here populated to our chassis as discussed before, and connected here to this 8-volt regulator. So the output is the input here of our 5-volt regulator, and of course our bridges, which we have done. One can be seen here, has been done on the side. So that is done, and of course here under our pre-driver I have put new thermal paste to be sure that the heat can go away. And yeah, so far we are more or less ready. Here's our little transistor which we have done new, and yeah, so far everything is fine. Now what I need to do here is, as discussed before, I put here a nut, and then that should be fine as well. Yeah, and the little nut is in place as well, and here our plastic is also back, so for the front panel, and yeah, fits quite nice, so no problem. So everything is wired up as it has to be, and well, already connected to the power supply. Let's see, when we fire it up right now, let's see what we have. Hey, that's great. That is great. So we have static, we have display. Yeah, we can operate it, obviously. So everything seems to be working. Okay, so that means now next step is, of course, we have to do a complete function test. As I said before, we need to check if the bands are all there on, and of course we have to check VHF and UHF as well. But I mean, first of all, that is very good. So our PLL fault is under control, and well, the wiring what we have done now is working as well. So as well our little voltage regulator down here. So yes, very promising, and now let's go ahead to perform some tests. Okay, so we have performed some testings, and well, the whole radio needed to get a full alignment. So I've never seen a radio which was so much out of spec like this. So yeah, we have really done a complete alignment, and now after all it seems to be quite nice. So we have everywhere on HF and 50 megahertz our 100 watt output, which was not given before, and all other settings was really misaligned. So the guy who worked on this radio before really was twiggling everywhere. So either on the transformers here or on the menu to set all the different stuff, so idle current, driver and exciter, and final stage, everything was misaligned. So never seen something like this. Now it is done, and finally yeah, it is okay, and we really can let it go back. So yeah, so radio is now really producing 100 watt SSB PEP output power, and you see we have a nice output pattern. Everything is fine right now in double tone test, and I have performed this testing on all different bands. And yeah, you see I'm feeding in here my double tone. And yeah, so far work is done. And I just bring back here the lid onto the radio, and then it can go back to its owner. Alright, that's it for today. If you like the video, please give me a big thumb up and hang around. There will be many more videos like this in the future. Bye for now.